afternoon. This is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. Today we will discuss the issue of bivariate econometric modeling. In the last couple of lectures, we have discussed various aspects of econometric modeling, that to various structure of data analysis, that to univariate analysis, bivariate analysis and multivariate analysis. We have discussed various issues under univariate analysis, various issues under bivariate analysis and little bit idea about the multivariate analysis. So, today the structure is mostly on the analysis of econometric modeling. So, let us start with what is all about the structure of bivariate econometric modeling. So, it consists of two aspects, bivariate setup and modeling. So, we have discussed what is the bivariate data structure and we have also discussed the modeling issues. So, let me first highlight what is the econometric issue behind the bivariate modeling. Econometric is the product of statistics. Basically, it is an extension of regression modeling. So, the basic idea of regression analysis is to start with cause and effect relationship between two variables, that is the dependent and independent variables. So, we like to know how the econometric modeling is very close, or you can say somewhat different from the basic statistical modeling. So, the basic idea behind regression analysis is to trust the cause and effect relationship, cause and effect relationship. So, it is also similar way of econometric modeling. So, here this issue is something different. When we will go for basic regression analysis, so we are not bothering about the various typical issues or typical problems behind this analysis. We have discussed the simple structure of regression analysis, but if we will go in deep or higher version of modeling, then the regression analysis is very complex and very complicated. And so far as econometric modeling is concerned, it is the root or beginning from this basic regression analysis. So, now when we will talk about the bivariate econometric modeling, then obviously the basic idea behind this issue is to study the cause and effect relationship between two variables. So, like here we have discussed this issue. So, that means it is cause and effect relationship between two variables. So, what is the cause and what is the effect? For instance, if we have two variables say x and y, then if we write y is a function of x, then x is represented as a cause and y represented as a effect. So, that means this is effect side and this is cause side, all right. So, now so far as econometric modeling is concerned, it is the extension of the basic regression modeling. Econometric modeling, the issue is on on the structure of research. So, there are many ways the structure can be analyzed. For instance, we are discussing here cause and effect relationship between two variables. There are many names we can describe regarding the cause and effect relationships. For instance, it can be the relationship between independent variables and dependent variables. Okay. Otherwise, it is also the issue between explanatory variable and explained variables. Okay. So, the structure is like this: independent to dependent, explained to explanatory. Then similarly, it can be also represented as a predictant. This is predictor and it will stand to predictant. Okay. Predictant, all right. So, similarly, it is otherwise known as exogenous variables. Exogenous variables and this is otherwise known as endogenous variables. Endogenous variables. Okay. So, similarly, it is otherwise known as stimulus, and this is otherwise called as a response. This is otherwise called as a regressors. This is otherwise called as a regressant. Okay. So, likewise, there are various ways it can be represented. So, it is cause and effect relationship, the issue between or the nexus between dependent variable, independent variable, explained variable and explanatory variables, covariance and covariate, then similarly exogenous and endogenous variable, stimulus and response, then last but not the least is called as a regressor and regression. Because econometrics is a statistical technique which has many application in many areas. There are various ways it can be represented, means the paper is mostly on application oriented. So, as a result the same words it can be represented in a very ways, means many ways. So, it is just like old wine in a new bottles. So, the pictures are almost more or less same, but the representation is somewhat different. So, before we start with this bivariate econometric modeling, let me highlight what is the issue behind this bivariate econometric modeling. The bivariate econometric modeling, since the issue starts with the bivariate, then obviously there are two sets of variables. So, one we call it x and another is you can say y. So, before we enter to bivariate econometric modeling, we must have essential requirements, otherwise we cannot do anything for this econometric modeling. So, now the issue is what are these essential requirement before we proceed for econometric modeling, that to bivariate analysis. So, first thing is number 1, conditions or constraints, conditions of bivariate econometric modeling. So, what are the conditions we need to have to build a bivariate econometric modeling? So, number 1 condition is that first is there must be two variables in the system. There must be two variables in the systems. So, let us say x and y or x 1 x 2 like this. Okay. So, this is first and foremost condition of this particular problems. Okay. Second issue is there must be classification of dependent and independent. So, dependent variables and independent variable classifications, because since it is the cause and effect relationship issue. So, obviously, there is a dependent structure and there is a independent structures. So, when we talk about cause, it is usually represented as a independent structure, and when we will call it effect, it is called as a dependent structures. So, the issue is when we talk about bivariate econometric modeling, then there must be two variables in the system. This is the first condition, and second condition, you have to classify which one is dependent and which one is the independent, because the model is based on that systems. Of course, there is you can say bidirectional causality issue. So, obviously, when there are two variables in a particular systems, so then either x causes y or y causes x, or both can be go simultaneously. So, that particular structure is called as a time series issues. So, we are not in the process of discussing the detail about time series modeling. So, we are just in the process of beginning. So, as a result, so this restriction must be here, that to the bidirectional issue or reverse causality. So, we are not considering here the reverse causality. That means, if x influence y, so we are assuming that so y does not depends upon x, y may depend on x, but y cannot be treated as a again independent variables. So, that means, dependent and independent classification must be very essential and very you can say accurate, or that is a right choice of this particular modeling. So, now third issue is there should be that means, in other words, it called as a n greater than equal to 2. So, n stands for number of variables in the systems, just it is extension of the first conditions for k must be greater than equal to 2. So, that means in this particular problem k is treated as a independent variables setup. So, when we will go for bivariate issue, then obviously k may be, or obviously k is exactly equal to 1. So, when we will go for trivariate modeling, then k equal to 2. When we will go for multivariate modeling, then obviously k greater than equal to 2. But for bivariate analysis or bivariate econometric modeling, if k is represented as the number of independent variables, then obviously in this particular setup k must be exactly equal to 1. Okay. So, that means in this particular for bivariate modeling, your k must be exactly equal to 1. So, k is treated as a number of independent variables in this particular systems. Okay. So, then finally, n greater than n represents here, the capital N represents total number of observations in the systems, and n represents total number of variables in the systems, total number of variables in the system. So, that means since in the it is a bivariate setup, then there are 2 variables. So, your sample size should be more than 2 at least. Okay. If your sample size is less than 2, then the system itself is inconsistent, we cannot proceed further. So, when there is a issue of multivariate, similarly the representation of a capital and small n will be very serious issue. So, for instance, for trivariate analysis, so obviously there are 3 variables in the systems, that means small n represents 3 and capital N must be greater than equal to 3. But even if it is equal to 3, the system cannot be operated properly. So, to operate the system properly, you must have sufficient sample size, or that means you must have sufficient data points. Until unless you have sufficient data point, you cannot able to, you can say, build the econometric models. So, your model building or the consistency of the model or the feasibility of the model depends upon the sample setup. Higher is the sample size, better is the accuracy of the model, or better is the feasibility of the models. If the sample size is very less, or you can say very minimum, then obviously it will affect the system, and the model by default it will be inconsistent one, and you cannot use this particular model for any forecasting or any policy use. For for the objective of policy use or forecasting, your model must be perfectly okay. So, what we otherwise called as a best fitted models. To get the best fitted models, you must have higher and higher sample size. So, that is the toughest issue in this modeling setup, that to econometric modeling. So, your sample size will be substantially or absolutely very high than the number of variable in the particular systems. So, there is a trick how to determine the minimum number of, you can say, a minimum sample size in a particular system. We will discuss in details when we will go in the deeper version of the econometric modeling. In the very beginning, so you must have knowledge that whatever variables you are using in a particular systems, your sample size should be absolutely greater than to number of variables in the system. So, this is the another condition of bivariate you can say econometric modeling. Then we are talking about 6th conditions. We are talking about 2 variables in the systems x and y, but we remember that there must be some variability in x and y. For instance, if I will take some observation on x and some observation y, if the observations are not perfectly okay as per the modeling rules and you can say modeling formalities, then of course, again the model will be you can say inconsistent or infeasible one. For instance, let us take a case here. If I have x variables and I have y variables, if I will take only x consists of so many observations like x 1, x 2, x 3 like up to x n. Similarly, y consists of y 1, y 2, y 3 up to y n. So, now x 1, x 1, x 2, x 3, x n, these are all implicity format. That means, we do not know what is x 1, what is x 2, what is x 3, what is x n, and we also do not know what is y 1, y 2, y 3, y n. Yes, what we can you can say represent here that x 1, x 2, x n are the sample points of x and y 1, y 2, y n are the sample points of y. But what is x 1, what is x 2 or what is y 1 or what is y 2, we have no idea. Now, I will give the structure here. Let us say x 1 equal to 2, x 2 equal to 2, x 3 equal to 2 and x n equal to 2. Then, in this particular setup, there is no variation on x samples. That means, every point it is 2, 2, 2, 2. If there is no such variation, then obviously, it by default the model will be inconsistent. Okay. So, there must be some kind of variability in the sample observations. It should not be highly distant or it should not be or you can say very equal. So, you have to find out the optimum one. So, that means, it is the midpoint or you can say somewhat middle between you can say exclusive equality and exclusive inequality. So, there should be some optimum one. For instance, if like the sample observation like this, instead of 2 to 2, if I will put x 1 equal to 1, x 2 equal to 2, x 2 equal to 4, x 4 is another sample is equal to say 7, then x n is another sample say 8, then there is some kind of variability. So, this particular setup is very consistent for the model building. Of course, by initial look these data points are somewhat okay, but still there is a statistical test whether these particular variables observations are absolutely okay or not, we have to verify it. So, there is a statistical technique. So, that means, we have to check the normal distribution structures before we go for any econometric modeling. Similarly, in the case of y, there should not be any problem like a 2 to 2 2 case. So, there should be some variability in y also. For instance, y 1 equal to 2, y 3, y 2 equal to 5, y 3 equal to 7 and y 5 equal to 8. So, that means, if the setup is some kind of variations, then obviously, there is a way to build a models. If all the data points are equal, then we sometimes very handicapped to handle the particular situation. So, we need some variability in the data points and that variability should not be so high. If it is high, then again it will turn to inconsistent. So, to make the consistent, it should not be absolutely equal and it should not be absolutely unequal. So, it has to be in between the two. So, that is what we call is a optimum ones. All right. Then seventh or last but not the least condition is that x and y should be random in natures. So, that means, somewhat it is attached with the issue of probability, means there is some kind of chance factor which can you can say involve in this modeling scenario, that to bivariate analysis. With this particular setup of you can say a condition of bivariate econometric modeling, we have to proceed further to what is the structure of this particular issue. Okay. Let us the basic structure of bivariate modeling, bivariate econometric modeling. So, bivariate modeling, the initial starting point we must have two variables y and x. Okay. So, here we will assume that x is represented as a independent variable clusters and y is represented as a dependent variable clusters. Okay. So, now the extension is like this, y equal to function of x. This is just like a mathematics. Okay. So, now Now, the extension is how you have to set this particular bivariate econometric modeling. So, let us y equal to the structure of y 1, y 2 up to y n, and x represents x 1, x 2 up to x n. All right. So, now when we have y and x, then we can trace the functional relationship between the two. Okay. When we trace the functional relationship between the two, then there are two different techniques we usually use, either correlation, that is the extension of covariance, and there is another technique called as a regression, that two extensions of again correlations. But so far as econometric modeling is concerned, there is something more than that. Okay. It is not just to correlate and just to regress. So, in between there is lots of hidden issues. So, that hidden issue is the crucial point of higher higher version of research, or you can say higher complex problem. So, now we have to discuss all these issues, and the beginning of econometric is that from this particular basic levels. So, when you have a particular relationship, that to correlation and regression, then there are various ways or various you can say by structure we can represent the relationship, and that to be perfect ones. To get the perfect one, we have lots of you can say structures, techniques, tools to get the better fitted. So, now we have to see how quickly we can have that particular best fitted models, and what are the problems we have to face, or we have to find out to get this best fitted models. So, this is very complex issue and very you can say typical issue we have to discuss step by step. Okay. So, let us start with this particular relationship. So, when we have two variables in this particular system having the observation y 1 y 2 up to y n and the observation x 1 x 2 up to x n, then obviously the first and foremost step you can say is that we have to build a mathematical form of the model, that is nothing but y equal to function of x, that is we call it a mathematical models. It is simply mathematical model. So, now when we have a variable in the systems, so first you transfer this particular theoretical information to mathematical information, that to the individual variables into some functional forms. So, that functional form is treated as a mathematical form of the models. So, now we have to transfer this mathematical form of the model into statistical form of the models, then the econometric issue will be coming into the pictures. So, now before we go to statistical form of the model, let us see let us just represent the explicit format of this particular you can say model or relationship. Y equal to function of x means there are many ways this y and x can be you can say worked out. So, what you have to do here, we have to see in a explicit format, that means whether the relationship is a linear one or the linear is a non-linear, because this is very strong issue for this modeling behaviors. So, let us assume that there is a relationship and that to linear relationship. So, now we have to represent y equal to alpha plus beta x, okay, just like it is a straight line equation y equal to m x plus c, where m is the slope and c is the constant. Here instead of putting y equal to m x plus c, we are putting beta x plus alpha. Beta is the slope and alpha is represented as a supporting factor, okay, constant factor, and x is independent variable, y is the dependent variable. So, this is what we call the explicit format of mathematical models. Okay. So, now this is the second step of this particular process, and this is the step 1 process of this bivariate setup. So, step 1 step 1 issue of bivariate econometric modeling is that we have to bring two variables and you have to build its relationship, and that too in a functional form, and that functional form again has to be in a explicit format. So, now when you have a explicit mathematical model, then we have to transfer into statistical form of the models. So, what is the statistical form of the models? That too we have to move into step 3. So, y equal to alpha plus beta x plus another term called as a u, where u is represented as a error terms, and this particular model is called as a statistical form of the model. So, we have simple y and x, then we have to transfer into mathematical form of the models, that to in a explicit format y equal to alpha plus beta x. Then again this particular model has to be transferred into statistical format, that is y equal to alpha plus beta x plus u. For instance, I will put it in different way. So, y equal to alpha plus beta x. So, that is mathematical models. So, then we are transferring y equal to alpha plus beta x plus u, it is statistical models. Okay. So, now the difference between these two models is with respect to this particular u term. So, u is represented as a error term. So, now the issue is what is this component u, why there is a u in this particular system and where you have brought this u. Initially we have, or our beginning is our journey is from y and x. So, now in between u is introduced in the system. So, now the question is why, because there is a debate about this issue. So, basically there is a always fighting between the mathematics and statistics. Mathematicians are always in the belief that everything is in exact, that means what is in the right side it should be exactly equal to in the left side. Okay. But statistician does not, you can say, like all these issues. They are in the view that there is something which is hidden in nature. So, that means nothing can exact in the society. So, there is always inexact process. So, that means something which we cannot exactly explore or we cannot exactly represent in the particular system. So, if you do not exactly represent in that particular system, then there is something gap. So, that gap can be filled through the term u, that is nothing but error component. So, that means if I will put this particular equation, so let us say this is equation number 1 and this is equation number 2. So, this is statistical form of the model. So, that means, so this is cause side and this is effect side, this is independent structure, this is dependent structure. So, now when there is a question of effect, so now there are two dimensions here, this one dimension is alpha plus beta x and another dimension is called as a u. So, that means alpha plus beta x is called as a explained factors. Okay. It is called as a explained factor. This u error term is called as a unexplained factors, unexplained factor, and this is called as a explained factors, and this is somewhat it is called as a total factors. So, that means the total effect depends upon from explained issue, that is what that is derived from the x issue, and which is not derived through x or through independent variables, then it will go to, you can say, u component, error component, that is not in your hand. So, that means all explained items are known to us, while u is unexplained in nature because it is not in your controls and we do not have any idea about that particular item. So, our target is to find out what is lacking in the system. So, that means how much we could not represent or we could not explain in this particular system. So, that is the main issue or main agenda of this econometric modeling. So, we like to know what is the error component which we cannot, you can say, have in the beginning. So, that has to be adjusted continuously. So, that means our objective is always we have to build a model in such a way where the error component should be at the minimum levels. So, that means we have to build, or the model can be, you can say, model can be represented as a best fitted if everything can be explained, nothing can be unexplained, but it is very very difficult to say something is totally explained and nothing is unexplained. So, there is a little, even if it is 1%, then also that 1% has also weightage sometimes. So, we have to see, or we like to know now why there is a error component in the particular system of statistical modeling. So, now the issue is why error component, in the issue of statistical modeling. So, our idea is to see why you like to use error component in the systems. Okay. So, now there are many ways we can represent this error issue. So, you see, we are in a bivariate systems, even if in the case of multivariate system error component is must. So, now the issue is, or our justification is why we like to introduce error component. There are many reasons for that. Okay. Why error components in the systems? Number 1, first is there are certain variables which can explain the dependent variables, but we are not in a position to include that variables. There may be many reasons for that, may be not available in our head with respect to information wise or with respect to structure wise, or sometimes what happens, even sometimes the idea is there, but we are not able to represent in a particular format, or sometimes we have no idea at all. Okay. Some variables may be affecting, but for the time being we are not in a position to represent which that particular variable which can also influence the y component. That means, some of the relevant variables, or you can say useful variables are not included in the systems. Okay. Included in the system. So, since some variables are not used in the system, so obviously there is some percentage which cannot be explained. So, that means there must be some error component. Okay. So, useful variables not included in the system. Second, some of the unnecessary variables means unnecessary variables or not relevant variables, unnecessary variables are included in the system, systems. Okay. So, this may be also because of this unexplained issue. So, there may be error term because some of the variables which may not have any contribution, but it will affect the system. So, as a result we have to introduce the error curve. That means, what is our commuting factors for this effect site. Okay. Third issue, there is a sometimes mathematical imperfection of the models. There may be sometimes mathematical imperfection of the model. For instance, so we are saying y and x, okay, y and x, and we are just putting y equal to function of x, all right. So, that to y equal to alpha plus beta x, that is our issue, but there are many ways alpha y and x can be represented. For instance, y can be alpha into beta to the power x, or y equal to alpha by beta to the power x, or you can say alpha beta to the power x, or you can say alpha plus x log beta. Like many ways we have to represent the relationships. Since for the time being we are assuming y equal to alpha plus beta x, then there may be some problems, technical problem or mathematical problem, and we at a particular point of time we have to use only one relationship. So, that means, at a time we cannot take y equal to alpha plus beta x or y equal to alpha into beta to the power x. So, yes, of course, what we can do, we have to test the model with a different function alpha. For instance, y equal to alpha plus beta x in one extent, and another extent we will take y equal to alpha into beta to the power x, and we have to set up different forms of the model, test the model to get the best fitted model. Out between these two, which one is the best, we have to consider finally, and we have to say that this is the best fitted model which we have derived on the basis of some decision making process. So, now likewise there are many ways the functional form can be established. So, now when there are many ways the functional forms are represented, then the model building structure will be completely different or also the result will be completely different. But there is a way what particular mathematical form has to be used. So, basically we will start with the simple one, and by chance we will get the best fitted model with the simple one, then we are in the right track. If the model accuracy is not on the basis of the above information or above functional form, then obviously we have to go one by one way, or we have to proceed one after another process to get the best fitted models. Okay. So, mathematical imperfection of the model also one of the committing factor which can you can say involve in the U issue. Okay. Next, fourth, there is a misspecification of the random terms. There is a question of misspecification of the random terms. We are always talking about x and y are random in nature. So, that means there must be some level of or some involvement of probability in the particular system. The term probability itself represents this chance of occurrence. That means something which is not in your control. Okay. So, now which is something not in your control means obviously that control may be in many ways. It can be at a higher level, it can be at a lower level, it can be at the medium levels. So, now what we have to do, since we have no idea whether it is higher one, lower one or medium one. So, we have to assume at least one, then accordingly that error involvement must be incorporated in the systems. Since we are not sure whether the impact is higher one, lower one or medium one. So, we have to do that. Okay. So, this is how the error is involved in the systems. Okay. Then fifth, there may be some question of lock in the systems. Take a case of social problems. For instance, you like to know what is the involvement of expenditure on a particular you can say sales revenue. So, expenditure that to lead to you can say advertising expenditures. So, now the theoretical knowledge is that if you put more and more investment on advertising, and obviously there is a strong impact on sales revenue. So, now the issue may be in something different, because we are discussing about one problem. So, that means we are discussing a particular issue, let us say this is a pen. So, now I like to know if there is some kind of investment on this pen advertisement, then obviously the growth or your sales of this particular pen will be in a increasing sequence, but you are not in a you can say monopoly situation. There are many competitors in this particular business environment. So, everybody is doing like this way. So, when there is a competitive issue, then obviously the formula is somewhat not direct one. So, you are involving, other people are also involving. So, by the way there are certain factors means which is again you can say third variable in nature can also you can say incorporate or you can say give the accuracy of the model. So, as a result there is you can say lock which can involve in the issue. Everybody is you can say objective that if we put more and more investment on advertising, our sales will go increasing. So, just we are believing that one. So, that means we are assuming that if we put more on advertising, then obviously sales will go. So, that means we are not sure, it is just not like a mathematical way. We will put 2 plus 3 you will get 5, you will put you can say 3 plus 3 you will get 6. It is not like that way, because we are putting something, then the effect will be somewhat in other way. That means, in between the cause and effect there are certain variables which can be also affect the system. So, as a result sometimes that factor may be considered as a log factors. So, that log because of you are not sure, and sometimes log is not supporting you for this particular issue, then obviously your you can say model cannot be accurate one or cannot be perfectly explained one. So, some part of unexplained is there. So, as a result error must be in the systems. Then last but not the least is called as a external factors. It is called as a external factors. External factors. Besides lock, there are certain factors which is not in your control. For instance, either you are not aware of it or it may be coming in, you can say, at the particular situation. So, in that context, since you are not sure or you are not certain, then obviously there is a error issue. For instance, take a case of terrorist impact. Okay. So, everything is planned in a proper way, we are very serious and we know all these variables are explained which is used in a particular system, and we are in the process to design that, build that, but unfortunately there is in between there is a terrorist activity. So, as a result there should be some inconsistent. Take a case of same thing in say in between advertising and sales. If putting more advertising and increasing the awareness among the people, so that your sales of that particular item can go on increasing, but by any chance terrorist attack on your plant say, then obviously your plant will be get damaged totally, and whatever investment you have done on advertising on that particular product, and that product cannot be also available for the market. I mean, since production is not there, so whatever amount you have put on advertising, it has no meaning at all, so it has no impact at all. So, as a result some of the external factors which are not in your control, as a result we have to put it in U component, that is error component. So, that means your error is always there in a particular system. So, that means when we will talk about statistical form of the model, so now we have to see what are the variables which are particularly explained in nature, and what are the variables which are not explained, that we will represent in the form of a U. So, that means U is treated as a proxy for unexplained variables, which is not known to us or which is not exactly identified. Okay. So, since we have no idea about it, so we are assuming that it is in U only. So, error will incorporate all these defects which is not in our controls. So, that means, so far as a bivariate econometric modeling is concerned, then the system will be like this. Our starting point will be y, then x, in between u is introduced in the system. So, now like this y 1, y 2, y 3, y 4 up to y n, then x 1, x 2, x 3, x 4 and up to x n. Similarly, y 1, y 2, y 3, u 4, sorry u 1, u 2, u 3, u 4 and u n. So, now if we go by simply mathematics, then obviously y 1 equal to x 1 plus u 1, okay. Y 2 equal to x 2 plus u 2, y 3 equal to x 3 plus u 3, y 4 equal to x 4 into u 4. Okay. So, similarly, y n equal to x n plus u n. So, that means all x are in one group and all u are in another group, and the total effect will be on y. So, this is explained effect, this is unexplained effect. Okay. This is unexplained effect. So, now our objective is to minimize this particular activities. So, that means the way we have to minimize, you need to have a best fitted models. So, you need to have a best fitted models, for instance like this. So, now if we will go by simple framework, then let us assume that for this particular variable your graphic structure will be like this side x measurement and this side y measurement. Since the functional form is y equal to alpha plus beta x, then alpha is a constant. So, this will be just supporting factor like this. So, now for every x 1, every x 2, every x 3, every x 4, okay, x 5 like this. So, x 1 there may be some you can say y 1, for x 2 there may be y 2, x 3 there may be y 3, x 4 there may be you can say y 4, x 5 then there will be y 5, okay, then x 6 then obviously y 6 like this. So, now if we join all such points, then the picture will be coming like this, the picture will be coming like this, and this is the true picture of this particular setup. So, that means we have y and y information and x information, and our idea is how y and x are related to each other. This is first objective, and if y and x are related to each other, how best can they be? They could be, you can say, related to each other. This is the basic objective behind econometric modeling. Obviously, when you will go for investing the relationship between y and x, there will be certain relationship, either you assume it, or by theory you have to bring this variable in such a way there is a somewhat relationship. So, that means that relationship is there, but we have to predict or we have to forecast how best they can be, you can say, related to each other. So, that the effect will be very positive and very accurate. Okay. So, that is how that should be our main agenda. So, as a result, within the particular setup we have to build a, you can say, line which is the best for you. So, that means if you will consider this is a path, and this path is very much uneven nature, it is not at all straightforward. Okay. It just like a non-linear one. So, that means we have to bring into a linear path, or you can say you have to bring in a best path, so that the model accuracy or forecasting can be very perfect one. So, as a result, let us assume that this particular line is the best fitted one. So, if we will say that best fitted one, in statistic we call it is the y head, okay, estimated line. So, this is what we call it is a estimated line, okay, or otherwise called as a expected lines. Okay, y head equal to alpha head plus beta head x. Okay, y head equal to alpha head plus beta head x. That means, in other way, so we have three forms of functions, y equal to alpha plus beta x. Okay, this is mathematical form of the model. Then we have alpha head alpha plus beta x plus u, this is simple statistical form of the model. Then we have y head equal to alpha head plus beta head x. When we will call it y head equal to alpha plus beta head x, this is estimated line. So, when we will say that this is the estimated line, this is the best line, this is the perfect line, then of course, the error issue will not be there. So, that means, the way we will choose the model is the best one. Obviously, as per your knowledge, it should be very explained one, it should be very explained one. So, if it is explained one, then obviously, the error will be not there in the system. So, that means, we first start with the exact model, then in between you have to assume that the model is not exact. So, that means, we have to bring the inexact of that particular system, then again we have to verify, or you have to come to the stage, again it will be transferred to the same exact model, that is in a way of mathematical form of the model. But the mathematical form of the model in a initial setting and the estimated model of the model in the later setting may not be exactly equal. Okay. So, here the issue of this mathematical form of the statistical form of the model is that we know this should be the relationship, that is the exact relationship. So, now why there is a statistic? Because statistic always object this particular mathematics. So, if there is a question of objection, then there is a need of information to verify that one. So, statisticians you can say assignment is to the way they will verify to that particular mathematical problem, mathematical form of the model. So, that the judgment can be accurate one. The same way the structure is all about the econometric model. So, now this is called as the best fitted model. So, now if we will integrate all these things, then we will have y equal to y hat plus E. So, this is the another form of the equation. So, that means your true value y, which depends upon estimated value and error terms. Okay. So, that estimated value may be perfectly okay, still there is a question of error term. So, we have to see how much error is committed in the system, and whatever error is that in the system, that should be in list. So, that is the more for accuracy of this particular system. So, altogether, so what we have discussed is that y equal to alpha plus beta x, this is mathematical form of the models, then y equal to alpha hat plus beta hat x, okay. This is estimated models. In between, so from the mathematical models, we assume that y equal to alpha plus beta x plus u is the statistical form of the model. So, this is what mathematical form of the model, this is what statistical form of the model, and this is the estimated model. Now, if we integrate all these things, then y equal to y hat plus E. Okay. So, now what is E? Is the other way or other way representation of error terms. Okay. So, because we have already in the estimation process, so obviously we are putting the error component some different name, so but it is more or less same. So, E equal to basically the difference between y minus y hat. So, that means what is the true value and what is the estimated value, that is the committee of error. So, error means, so what is the actual and what is the predicted or estimated, okay, or assumed value. So, we are assuming that this should be the perfect one. So, there should be actual. So, we like to know what is the difference between the actual and estimated. Okay. So, that difference is called as a error issue like this. Okay. So, these are the true value. Okay. So, we are assuming this is estimated value. So, now the difference is all about this error issue. Okay. So, these are all called as a error issue, like for E it called as E1, this is E2, this is E3 like this. So, this side is x measurement, this side y measurement, this is estimated models y hat. Okay. In between it is the integration between true lines or true points, actual points and the estimated point. So, now this is the typical issue of this, or this is the basic static point of econometric modeling. So, now what is our next objective? Our next objective is to minimize this error term. So, far as minimization is concerned, or of course, when there is a question of optimization, we cannot optimize the single one. So, we have to optimize the minimum sum of the squares. Okay. So, sum of the errors, square errors has to be minimized. So, that process is more complex and very interesting and very useful, very systematic. So, that we will discuss in next class. So, it is not possible to start here now. So, the detailed structure we have to discuss in the next. Thank you very much. Have a nice day.